Good morning, students. I hope that previous class or the previous lecture you have listened and it has been fun, right? For the first time, this sort of class is going on. You are sitting at home, and me personally also. But still, classes are on. I hope you enjoyed it. Still, if you're having any queries, probably you're having the email address of the teachers. So, of me or other teachers, whoever you want to contact, you can do that for your personal queries. All right. Okay. So, in the previous class, I started with chapter one of states. Chapter one, that was states of matter. And I'll continue with that, as I told you in the previous class, that the rest of the chapter, will be continued in the next class. So I'll continue with that. I stopped in the previous class the point regarding differences between solid, liquid, and gas, and also regarding interconversion of states of matter, right? Interconversion of states of matter, and I discussed about regarding the properties, right, of the solids, liquids, and gases, as well as regarding interconversion, the factors. The last point was the factors on which the interconversion of states of matter depends. The two parameters I told you, temperature as well as pressure. And I gave you one homework. If you remember, I gave you one homework, an assignment to find out what, or rather why. I discussed several examples, or rather on the parameter or the interconversion of states of matter regarding temperature and pressure. But one question I gave you to find it out, that why the inner core of the earth is solid despite the surrounding temperature is very high, almost 6,000 degrees Celsius, where almost all elements gets converted into the liquid form, but the inner core made up of those elements only is not in the liquid state. It's in the solid state. So I'll start today's class. I'll start with this particular question, and then I will move on to the next, or rather rest of the chapter. The reason is that why the inner core is solid. I hope many of you by this time have already got this answer. Yes, due to extreme high pressure. Inside the earth, that means at the inner core, as we go down inside the different layer, as we cross the different layers of earth, the pressure increases. And at the inner core, those points, those levels, almost 5,000 kilometers from the surface, deep. At that point, to those layers, the pressure is enormously high, almost 3.5 million times from the surface pressure. 3.5 million times, that means 3.5 million atmosphere. The surface pressure, we know that. What's surface pressure? The surface pressure is 1 atmosphere. Probably you have read this one probably in physics, or if you haven't, then you will definitely in this class. Some of you probably know this one. You might have read in geography, or if not, then it's possible that you will know. You will read this time. The surface pressure, that means where we are living right now, this surface. The surface pressure is 1 atmosphere, and inside the earth, that means at the inner core, the pressure is extremely high, 3.5 million atmospheres, such a huge pressure. What happens is it increases the interparticle force of attraction. That means the particles, that means the substances by which inner core is made up of, as we know that inner core is made up of what? Inner core is made up of iron as well as nickel. Now iron and nickel, their melting point, the melting point is what, rather it gets converted into liquid state at a temperature around 3000 degrees Celsius, 3500 degrees Celsius, someone 4000 degrees Celsius. But in presence of such high atmospheric pressure, such high pressure, not atmospheric pressure, rather such high pressure, the environmental pressure is so high that it compresses the molecules, it's rather so closer, and the bond and the particular force of attraction becomes so high that the temperature, it overpowers the temperature, and the temperature is unable to break the bond, break the force of attraction existing between the particles of the inner core, and thus the inner core remains solid. Clear? All right. Now, apart from this, now coming to the, this was the homework given, so I discussed about this point. Now coming there, there are certain terminologies. I in the previous class, I discussed about the different, what is interconversion of states of matter. I repeat, that was basically conversion of solid to liquid, or liquid to gas, or back from gas to liquid, or liquid to solid, or maybe from solid to gas or gas to solid. So these total, all these conversions, interconversions from one state to another state, that's basically called interconversion of state of matter. And there are certain terminologies related to this interconversion of states of matter. There are certain terminologies, mean there are certain terms which we need to be familiar with, because those terms are highly related. Those terms are highly related with interconversion of states of matter. Each and every time we will be requiring those terms when we are discussing about interconversion of states of matter, or other any conversion of states of matter. Okay, so let's get started with interconversion of states of matter, or rather terminologies. The first term is what we call as melting. What is melting? Melting is a phase change. So we need to understand these things very clearly. You don't have to panic yourself. Don't get panicked. Regarding, I previously also I told you that just close your books. In my class, you don't need books every time. Just close it and keep it aside. You don't need books right now. Books later on. For the time when I'm discussing, just listen to it, clear your points and clear those, what I'm telling, just clear your concepts. That's all. And I hope that once these things will becomes easier, you're having a very, very clear conception about these things. When you will go through the book, it will be almost as if you're just having a very, very simple thing with you. All right. So books not required right now. Whatever I'm telling right now, just follow that one. Study materials definitely will be provided, as I'm providing, or rather you are already got that one. The study material. Similarly, you'll get the materials accordingly from my side. Just go through those material. I mean, those are basically pages or the chapters which I'm discussing. Okay. Exercise books not required right now. Only you need the exercise book, that means copies. Exercise books you only need when it's time for solving exercises. Apart from that, when it's time for solving exercises, you only need that book or other exercise books. Later on, or other than that, not required. Okay, so let's continue. So melting is, what is melting in simple terms? Solid becoming liquid. Solid becoming liquid. And how this solid becomes liquid? By the absorption of heat. So when we heat up things, then when we heat solids, it automatically transforms itself into the liquid state. That means temperature. Previously, I told you, or we have already known that two parameters are essential: temperature and pressure. So over here, temperature is leading to a conversion of the solid to the liquid form. Example, ice to water, solid wax to molten wax. We know that candle, when it burns, it gets converted into molten wax. All right. The next is melting point. What was melting? It was basically a process. Solid to liquid, the process, the conversion by the process. And what about the melting point? It's basically the temperature. The temperature at which, that means this process, the temperature in the melting, I told you that I'm providing heat, and ice is getting converted to water or any other absorption. Now at that there are definitely at certain temperature these things will happen. For example, that if you heat iron, will it melt? If you heat iron in a normal, you have seen that we are cooking, you are using iron pots or any other iron vessels or aluminium vessels. Over there we are using those things, but does it melt? No. So normal only heating will not lead to the change of solid into liquid until and unless a certain temperature is reached. That conversion of the state will not take place. So what is melting point? It is the temperature at which a substance melts, that means gets converted from the solid to the liquid form at STP. Now this STP is very, very important. Do not forget to write this STP. I repeat, do not forget to write this STP with melting point. What is this STP? This STP is standard temperature and pressure. The full form of STP is standard temperature and pressure. All right. Now coming to the next, that is evaporation. What is evaporation? Now once again, heating, liquid to vapor conversion. Liquid to vapor conversion. That is the process by which liquid gets converted into its vapor state is called evaporation. Next is boiling. Once again, boiling is liquid to vapor conversion. Liquid to vapor conversion. That means liquid will convert into its corresponding vapor state. Vapor means gaseous state. Now the question you may think or may ask that, then what's the difference between evaporation and boiling? Evaporation also, liquid is getting converted into its gaseous state or in the vapor state. Boiling is also getting converted into the liquid state or in the vapor state. And what is the difference between these two? The difference is, number one, boiling takes place, boiling is a very fast process, and evaporation is a very slow process. With boiling takes place at a particular temperature. That means this liquid to vapor conversion will occur at a particular temperature. And evaporation occurs at all temperatures. At various temperatures, or rather better to say at all temperatures, evaporation takes place. Okay? So there's a very, very significant difference between evaporation and boiling. Now, as I discussed in the previous part, that is, what is regarding melting point, similarly, we are having the boiling point too. The temperature at which substances boil. That means boil means gets converted into the liquid into the gaseous state, but at STP. Remember, with melting point we added this word STP. With boiling point I added also STP, but with evaporation I didn't, because boiling point, this temperature, that means the liquid boils at a particular temperature at STP, at standard temperature and pressure. For example, boiling point of water is 100 degrees Celsius at STP. Do not write the boiling point of water is 100 degrees Celsius, that's all. No. Without this STP, your statement or your term that this is boiling point of water is 100 degrees Celsius is totally wrong. Is totally wrong. Because this STP is very important. Because under standard temperature and pressure, this condition only water will boil at 100 degrees Celsius, otherwise not. So it's very, very important to mention this term STP. Coming to the next definition, that is, next term rather, condensation. Now, if you noticed, I started with melting, that means I was basically adding temperature. I was basically giving temperature to a substance. So the phase change from the solid to liquid, liquid to solid, this conversion, this change is called a phase change from the solid phase to the liquid phase to the gaseous phase. So from the solid phase, this is what you call as phase. And this phase change, I was accelerating in a manner, that means by accelerating the temperature, increasing the temperature. All right. Now I will decrease the temperature. And on decreasing the temperature, definitely, if adding the temperature converts solid to liquid, a liquid to gaseous form or the vapor state form, then definitely reducing or decreasing the temperature will revert the situation back. That is, from the gaseous state or the vapor state, it will come back, the substance will come back into its liquid state by reducing the temperature, mind it, by reducing the temperature. The next, so condensation is a process by which gaseous substances or gases do convert into its liquid form by releasing heat. It releases the heat, right? Okay. What is condensation point? Definitely the temperature at which substances cool to form the liquid. Now, it's a very interesting thing, that is, the temperature at which water boils, that means the boiling point of water, is 100 degrees Celsius at STP. So, under circumstances, the boiling point of water is 100 degrees Celsius at STP. Similarly, the condensation point of water is also 100 degrees Celsius at STP. This, if the phase gets changed at 100 degrees Celsius at STP from the liquid to the gaseous state, then similarly at 100 degrees Celsius only, this reverse thing will happen. That means from the gaseous to the vapor state. But there is a but. If I am considering this condensation point, the temperature, as I said, I can only mention this, that means the condensation point of water is 100 degrees Celsius, only when I'm considering the reference frame. That means this is with respect to boiling point. This 100 degrees Celsius is with respect to boiling point of water. But if I only write the condensation point of water is 100 degrees Celsius at STP, then it's not fully correct. Because until and unless I mention the reference, that means if, how will I give the example over here? Water vapor to water liquid. That's a condensation basically. That's an example of condensation. That's not the example of condensation point. And what's the example of condensation point? The example of condensation point is If we need to give an example, we have to first that if water boils at 100 degrees Celsius at STP, then definitely the condensation point of water will be 100 degrees Celsius at STP. Clear? Because there is a reference of evaporation also. Because by that process, water also gets converted into its vapor state. And it takes place at different temperature. It takes place at 40 degrees Celsius temperature. It takes place at 30 degrees Celsius temperature, even at 5 degrees Celsius temperature. So the temperature, there's no fixed temperature. Evaporation occurs at varied temperatures. And hence, for this reason, we need to mention our reference point or reference point that from what thing that we are stating that the condensation point of water is 100 degrees Celsius at STP. So it's better to write a full complete sentence that if the boiling point of water is 100 degrees Celsius, considering, then the condensation point of water will be 100 degrees Celsius at STP. Clear? Okay. The next certain terms coming to freezing. So now we have already converted gases into liquid state, into liquids, right? Now there will be more reduction in the temperature. More reduction. That means I will reduce the temperature a lot. And such reduction in temperature will lead to what? Once again, from the liquid to the solid state conversion. As I said, if the reduction in temperature leads to the conversion of gases into the liquid state, then again, conversion of, or rather reduction in the temperature, that means the surrounding temperature or the temperature of the substance, that temperature of the liquid itself, it will lead to the conversion of the liquid into the solid state. Again, phase change. And that phase change, this freezing, it's called freezing. It's called freezing. Okay? Along with freezing, a term which comes up, that's called the freezing point. Similar, the temperature at which substance is cool enough to form a solid at STP. So once again, we need to mention STP, freezing point of water at STP is 0 degrees Celsius. That means ice, formation of ice. Ice forms at 0 degrees Celsius, provided you have to mention at STP. That means water, the freezing point of water is 0 degrees Celsius. Once again, the condition STP. The next term, sublimation. What is sublimation? Now, previously I started with a solid substance, heated it up, went to the liquid, the intermediate form, again heated up, went to the final one, that's the gaseous state. Again, cooled, the gases came back to the intermediate liquid state, and then further cooling led to the formation of the solid. Now, sublimation is the intermediate will not be there. A direct conversion with the application of heat. And with the application of heat, the direct conversion from the solid to the from the gaseous state. Sublimation is solid to gas conversion. That means a solid will get converted into its gaseous state, or in the vapor, will form its own vapors in the gaseous state with the application of heat without having the liquid state. So a direct conversion of the solid into the gaseous form. Naphthalene, we are very much familiar, habituated. We have seen naphthalene. We use it in our daily life, right? We are having it at our homes. Naphthalene we use in cupboards or any other places. What do we see? That we just keep a naphthalene balls or naphthalene blocks wherever, and after a certain point of time, we see the naphthalene vanishes. There is no trace remains, and there is no liquids also available. It's not that wherever we are keeping, suppose we are keeping this naphthalene inside clothes or anywhere else, we have seen that the clothes become wet, or the place where we are keeping is having a very liquid trace or something like that. No, we are not happy. We haven't seen such things. So that's called the sublimation. So naphthalene, camphor. So all these are sublimable substances. Sublimable substances which undergo the process of sublimation. Sublimation is basically the process name. Be very careful. Process name. Coming to the next, liquefaction. What is liquefaction? Once again, gas to liquid conversion. Now, what's the difference between condensation and liquefaction? Condensation is also conversion of the gas into the liquid state, and liquefaction also gas to the liquid state. But the primary difference between the condensation and liquefaction is the role of pressure. In condensation, did I mention the role of pressure? No, but in liquefaction we need to include the role of pressure, because this conversion of gas into the liquid state will not only take place by reduction of temperature. That means I will reduce the temperature, but the gases will remain in the gaseous form. The gases will remain in the gaseous form. It will not get converted into its liquid form until and unless we are applying pressure. Applying pressure, we need to increase the pressure. We need to increase the pressure. That means we need to compress. So under high pressure and low temperature, the gases gets converted into liquid, and thus that's called the liquefaction. For example, preparation of liquid nitrogen. Preparation of liquid nitrogen under pressure. LPG cylinders, in the previous example I gave you as application of pressure, the LPG cylinders which we are having, it's containing liquefied petroleum gas. So when we open the cylinders, we get gases. But inside the cylinders, we are having the liquefied gas. That means the gas is present in the liquid form. So the liquefied petroleum gas. So preparation of liquid nitrogen, the entire cylinder, how it probably is basically used. Liquid nitrogen cylinders, liquid oxygen cylinders, they are basically used in research labs. And those liquid nitrogen and oxygen preparation includes that we need to lower the temperature. And as well as probably almost of 1A minus 180 degrees Celsius, 190 degrees minus 190 degrees Celsius, and high pressure. So under such circumstances, these gases gets converted into the liquid state. That's called the liquefaction. Clear? Okay. So over here, I'm showing you everything, all the phase changes. If you go through this one, it's basically all these terminologies shown in a chart diagram. I have shown this one in a chart diagram. All the terminologies, what I discussed previously, is being shown in a chart diagram. Now, when you are going through this chart diagram, probably you may come across certain terms where you can be confused. What are those? Number one, melting is also having another name that's called fusion. The next, condensation in bracket, it's written liquefaction, but condensation and liquefaction are not the same thing. In bracket, melting and fusion are the same thing. What is melting and what is fusion? They are the same thing. But condensation and liquefaction, they are not the same thing. Alright? Liquefaction is by the role of pressure. Condensation does not include the role of pressure. Sublimation, the opposite of sublimation, that's called, if solids are getting converted into gaseous state, or the gases, then gases from solid to gas, it's sublimation. From gas to solid, it's called deposition. This term, which I missed previously or didn't include in the list, that was deposition. So over here it's mentioned, from solid to gas, it's called, what it's called? Yes, sublimation. And from gas to solid, it's called the deposition. So deposition and sublimation. Along with this, so boiling or vaporization, same thing, no problem. You may come across one term that's called the latent heat. Latent heat is basically, as I said as I said previously, that if regarding the while discussing the condensation point, that if phase change, that means liquid can get converted, if liquids can get converted into the corresponding gaseous state by absorbing heat, that means at 100 degrees Celsius temperature, then at the same temperature at STP, the gases can cool down from the liquid. So there is no change of temperature. So latent heat is basically involved. This word latent heat is, you will come across this term latent heat in physics if you're having the chapter heat. This term is related to phase change. That means whenever the phase change is taking place from the solid to the liquid, from the solid to the liquid. So when the solid is taking up the heat without increasing its temperature, solid is taking up its heat without increasing its temperature, it is converting itself into the corresponding the liquid state that is basically called the liquid state. Then such conversion involved, such heat is called the latent heat. Similarly, liquid to gas or the gas to liquid, it involves latent heat. This word latent heat is related to phase change. So whenever there is a phase change is taking place from liquid to gas, the temperature does not change. That means temperature of the substance does not, or the matter, state of matter does not change, but only the phase change takes place. All right. Now related to this, there is a video which I want you to see, or rather, see that will the entire this change of matter, there are states of matter into conversion. It's a demonstration given. It will help you out. Just look at it. Okay.
Namely, solids, liquids, and gases. The change of substance from one physical state to another is called change of state. Change of state occurs due to heating or cooling of the substance. When a substance is heated, its molecules start moving faster and the intermolecular spaces increase. Gases expand the most, while solids expand the least on heating. Fusion or melting is a process in which a solid changes to liquid state at a constant temperature due to absorption of heat. This fixed temperature is called the melting point. Example, wax melts at about 63 degrees Celsius. Ice melts into water at 0 degrees Celsius. On application of heat and pressure, the internal energy of a substance increases, resulting in a rise in its temperature. As the temperature reaches the melting point, the molecules of the solid gains enough strength to break the molecular force of attraction, resulting in liquefaction. Freezing is a process in which a liquid changes into solid state at a constant temperature by releasing heat. This fixed temperature is called the freezing point. The melting point and the freezing point is same for any substance. Example, the freezing of water liquid into ice solid at 0 degrees Celsius. When temperature is lowered, the molecules come closer to each other. Gradually, they solidify. Vaporization or boiling is a process in which a liquid changes into its vapor state at a constant temperature by the absorption of heat. This fixed temperature is called the boiling point or the vaporization point of the liquid. Example, the vaporization of water liquid into steam gas at 100 degrees Celsius. When any liquid is heated, its temperature rises until it reaches its boiling point. The temperature will then remain at that point until all of the liquid is boiled away. Condensation is a process in which vapors change into a liquid state at a constant temperature by releasing heat. This fixed temperature is called condensation point. The vaporization point is same as the condensation point for any substance. Example, the conversion of steam, gas into water, liquid at 100 degrees Celsius. Sublimation is the process in which a solid directly converts into gaseous state. Example, sublimation of camphor on naphthalene. In this process, the solid does not pass through the intermediate liquid phase. The process requires additional energy. Solidification or deposition is a process in which a gas condenses directly into solid state. Example, conversion of carbon dioxide into dry ice.
Alright, so that's all for the video. Now coming to the next part, that is law of conservation of mass. This is another part. It's law of conservation of mass. What is law of conservation of mass? The law of conservation of mass states that mass can neither be created nor it can be destroyed in a chemical reaction, but it can be transformed from one form to another form within the reaction. What does that mean? That means if I'm taking 10 gram of the reactants, then definitely after the reaction there will be 10 gram of the products, considering all the products we need to consider. If 10 gram of the reactants, the total mass of the reactants are 10, or rather is mass of the reactants is 10 gram, then the total mass of the products will be 10 gram. So mass can neither be created nor it can be destroyed in a chemical reaction, but it can be transformed from one form to another form. Or suppose you may encounter a reaction where the reactant mass is 10 gram, but somehow you have taken all the precautions, but there is a loss, some percentage, 0.001%. You are not seeing that. You can see that 0.001% or 1% instead of 10 grams, you are getting back 9.9 gram of the products. So you may conclude that there is mass loss. No, the mass is not lost. Basically, it may get transformed. As I said, transformation is possible, so it may get transformed. It got transformed into any other forms, and the opted form is energy. So mass can neither be destroyed. We cannot create it. We don't have the power of doing that. We cannot destroy it, but we can transform the mass from one form to another form. The examples, so if we are taking for example, the total mass of barium BaCl2 is barium chloride and sodium sulfate, Na2SO4. So if we are taking a total mass of barium chloride and sodium sulfate as probably 10 grams, then the product of barium sulfate and sodium chloride will be 10 grams also. For this, once again, I'd like you to see a video again, where you will be able to understand this one more clearly. All right.
Model. In today's experiment, we are going to demonstrate the law of conservation of mass. For this regard, we are going to react iron-3 chloride with silver nitrate solution. Before we do that, we have here an analytical balance to calculate the mass, to measure the mass before and after the reaction. So at first, I'm going to put the flask on the balance. And in the flask, I am going to add a little bit of iron chloride, iron 3 chloride, and I will dissolve it in water. This is the iron chloride. So I'll add iron chloride over here. And we will add water solution. So now we dissolve the iron chloride. In another test tube, we are going to add to it silver nitrate, a solution of silver nitrate. And this silver nitrate solution will drop it in the flask. The reactants did not mix yet, and we're going to close this and measure the mass. The mass looks now 210.84 grams. Okay? Now, I am going to let the two reactants mix together in order for a chemical reaction to occur. As you can see, I have here a solid white powder forming still in the test tube, and a cloudy solution also remaining in the flask. Now let's measure the mass after the chemical reaction. And the mass is still the same.
So you have noticed and you have seen that how this mass does not get changed. Okay, so that's all for this chapter, and you're having the homework, that's exercise of chapter 1, and probably I'll discuss the exercise of chapter 1 in the next lecture, of course. So till then, practice. You'll be having the assignments with you, or rather the exercises with you. Start solving, and in the next class I'll be discussing with the exercise of chapter 1. Till then, stay safe, stay at home, take a very good care of yourself, and thank you.